Well, hello there. Hello there. I hope everyone is well. We are so excited that you joined us today for our presentation. I am super excited to be able to have with me my amazing colleague, Kelly Reddin, and we are equally as excited to be able to share with you about our Spike Prime program, getting your students excited about computer science utilizing Spike Prime. I am Sonya Glasper, and I'm the rep here for the state of Georgia. And I absolutely love my position here with Lego Education. I have had the opportunity to be able to be a part of this community for 20 years. And so I am equally as excited to be able to be a part of the Lego Education family. And so looking forward to being a part of yours there in your districts. And so, with no further ado, I will introduce my colleague and a good buddy, Dr. Kelly Reddin.
All right. Well, thank you, Sonya. My name is Kelly Reddin, and I am a Global Master Trainer and Solutions Engineer with Lego Education. And probably more important than that is I'm a former teacher. So I taught first, third, fourth, fifth, sixth, seventh, and eighth grade. And lots of fun along the way. Most of my time was spent in middle school, and what I'm going to share with you today is something that's near and dear to my heart, and that is computer science for those middle grades, those middle school kids. So let's get started with this. We will talk about how familiar are you with Lego Education. So if you are, really, I just know a lot about Lego Education, I'm going to let you put magenta into the chat. If you are, I know a little bit, put yellow in. And if you are really, I know about Lego retail, all the Star Wars and other things, but not the education, you can put blue. So I see that we have a yellow out there. And I don't see any magenta. So what I'm going to do is I'm going to give you just a quick and a blue, a quick update on where we are. So Lego Education is one small part of the big Lego group. And that big Lego group has about 17,000 employees throughout the world, and Lego Education has 250. So we're really a tiny part. But what is so great about that is we have so many people who are just passionate about education, many former educators, and people like Sonya who have worked in the education business for years. And why do we do it? Because we love children and we want to see them succeed. And actually, that's the mission of Lego Education, is to provide materials so that all children can succeed and they become the builders of tomorrow. When we say builders of tomorrow, we don't mean, those are the kids who are going to grow up and be adults who play with Lego bricks. No, we're talking about the builders of our society, the builders of the problem solvers of tomorrow, who are willing to take a small risk and prudent risk and try something new and think about something in a different way, be creative to solve those issues of tomorrow. Now, when we talk about Lego Education, there are materials that we have that are the bricks that you work with, but we also have curriculum, and the curriculum is free. And then we're going to talk a little bit later. We have professional development where we actually can do it virtually, but we love to come out in person and come to the schools and do hands-on with you. But we also have an online tool as well. So that being said, I'm going to move on to ask you, what is computer science? When you hear that term, computer science, what do you think of? So if you don't mind putting some answers in the chat, when you think of computer science, I know some people think immediately of coding. Some people think of programming. That's right. Some people think of computer science like building a computer, the hardware. So there are a lot of things. I love that. Laura says it's ever evolving, and that is absolutely correct. True, Laura. It is not a stasis type of thing. It is really very much fluid. So I'm gonna move to the next one and say, I think what we need to do is start with what Georgia defines computer science as. Since we're working in Georgia, let's look at what they say. They say it's the study of computers and algorithmic processes, and people go when they hear algorithmic processes. It's step-by-step instructions. Let's not get more scared. It's not calculus. It's step-by-step processes, and then includes the principles, the hardware and software, all the devices, the models, robots, etc., and the software that runs them. So how we do that programming or encoding, but it's more than that. It's also how do we implement it and what impact does that have on people? So we can make things that are robotic and that are part of computer science, like a self-driving car. But what are the impacts on society? What decisions do they have to program into those cars that affects us? Oh, a lot of those. So the standards also should blend with the core concepts of computer science. So it's not like, okay, we're just going to have computer science and we're going to teach this one thing over here. But it also should be blending what students learn and know with what they should be doing. And finally, it should be taught integrated. So it's not, oh, we're going to have this one course and just like we would say, oh, we're going to have a math course and we're only going to learn multiplication, but we're never going to learn where to apply it, but we're learning it. That's not what we want. We want that integration of all of our courses and all of our information and application so that they see there's a real place for it. Now, one of the things that I love is that Seymour Papert looked at computer science years and years ago and said a good computer science program should have a low floor, meaning it's easy to get started for teachers and for students. But it also should have a high ceiling so that no matter where someone is coming in, where they're developmentally ready, there should be opportunities to grow. And they should be able to really get more complex over time to push up, no matter where they came in at. And it should have wide walls, meaning that we should be able to get interested from different aspects, everybody, because we know that we have lots of different interests and learning styles. Everybody's a little bit different, but we should be able to accommodate everyone and still maintain that interest. So here's what I worry about. I worry that some things are really easy to get started in with that low floor, but they don't go very high. I mean, you're quickly running out of stuff. And then there are some that are only have a very narrow, spread of things that are interesting to kids. And so you're leaving out the all in CS for all, because we have to remember we're trying to reach everybody. Okay. Everybody includes not just a small segment of the population, but we're trying to get kids in the programs that have never done anything with computer science before. It's all brand new. And somebody who
Kelly, we lost your audio.
Hi, Sonya. Hi, Kelly. Oh, I think, don't know why it's muted. Let me see.
Hello there. Hi, Lynn.
Okay. Can you hear me okay?
Yes, I can hear you, Lynn. Can you hear me?
Yes, I can hear you.
Okay, looks like Kelly lost her audio.
Okay. So
It looks
I
like
think she's
I
trying
think
to
she's going
exit
to
and
try to
come back
come back
in.
in, Lynn.
No, still not working. How about refreshing your page? Yeah, that will send her out, but maybe coming back in.
Coming back in to refresh the page. Okay.
Yeah. Okay. Just give her a second to do that.
Okay, sounds good.
Can you hear me now?
Yes, we can hear you now, Kelly.
Okay, sorry. I had to leave and come back.
That's yes.
So sorry. I don't know what happened. All of a sudden, I was just muted. So, so anyway, we're gonna move on from Seymour Papert and go to the next slide. So what we're going to talk about today are the foundations of physical computing. It is a course that was written specifically for middle school and can go into ninth grade. So it is a hands-on, minds-on course for computer science. So when we say foundations of physical computing, it is written to the CSTA standards. It takes a path. There are 10 units. And in those 10 units, they go from what is a robot and very beginning, getting started of programming, like how do I turn on a light and how do I make a motor run? How do I use a sensor? All the way through until we are doing compounded, nested, conditionals. And so it's a wide range. So we go through and it takes a semester to go through the entire course. And in that course, we are integrated again. So yes, it's computer science. There's some engineering. There's some science. There's a lot of English language arts built in where kids are going to have to work together. They're going to have journaling. They're going to have presentations. They're going to have to create an argument and develop it and prove their point. So they've got a lot of different things going on. And of course, math. So we've got this nice package. And included in that is something that the CTE folks will really like. And of course, it's optional. It's like everything else. I mean, when I was teaching and somebody handed me a book or a program and I would read through it, and I will tell you that I never followed it exactly. I took what I really liked and left some behind, or I changed what they were going to do. And I fully expect you to do that. Okay, because you are the expert in your classroom. But what this gives you is it gives you a nice tie-in for career. So when we're trying to get kids to open their mind up to being more than the exact same thing that they see the people right around them doing for a living, and we know that by the time they get to uh, graduation from high school, there are going to be new jobs. My job did not exist when I graduated from high school, when I graduated from college. This particular job didn't exist when I first became an employee of Lego Education. So we have to continue to learn and to grow So we want to give them those mindsets, but we also know that we are trying to help them learn about what's out there right now, even, and see trends and see skills that are applicable to everything. So we go through all 16 career pathways, and every unit ends in the end with an open-ended project for computer science, and they're going to learn and have a little open-ended project for careers. So they'll look at 2 different career paths in every one of the first 8 units, and they're going to also do a self-reflection. How well do I, or what skills do I have now? What skills do I need to learn? And then through the course, they're going to have practiced several and say, well, at the end, looking back now, I've grown in these areas, and this is where I think I'm interested. And then they're going to make a little plan on how they could get there. So that gives you a little bit. So again, focuses on computer science. It's going to have that career component. And then at the end, we have these big culminating activities. One is a culminating activity for careers where they are given a real world situation and they must be able to look from all 16 career pathways. How do those jobs and careers affect the people in this situation? And then for computer science, they are given several real world applications, and they have to choose a problem and try to come up with a solution to it and build a model that is programmed and then do a presentation. So before we get there, though, it's really easy to get started. I mean, very easy to get started. All the lessons are 5E lessons. They are all standard aligned. Like I said, the focus is going to be on CSTA standards, where we are applying what they're learning to the real world. So it's not, you'll never hear, why do we have to know this, Mrs. Reddin? That's never going to pass their lips because they're going to see that application immediately. And then at the end, they are going to take it to the next step of applying it into culminating. So what I want to do is something fun for you today. And I want to show you an example of something that is computational thinking activity. You're going to need a paper and a pencil. And what I want you to do is just quickly draw a 4x4 grid. So this is the type of a engage activity where we're getting them ready, their brains kind of getting together on what we're going to learn how to do in the day. So what we're going to do is we're going to talk to them about computational thinking and how you would decompose, which means breaking down into little pieces, some big projects. So you try not to eat the elephant all at once, taking a bite here and a bite there. We're going to generalize by recognizing some patterns. We're going to think algorithmically. Again, that's solving it one step at a time, not going, oh, calculus. No. This is just one step at a time problem solving. Evaluate by, looking at what we've built, saying, could I make it any better? Ooh, it's not quite working the way I anticipated. I better go back and debug it. So we're doing that. And then, of course, we're going to abstract and then explain our ideas and what concepts we have. So what we're doing is we're taking that square and dividing it up into 16 different squares. We have 4 quadrants. We have 4 rows and 4 columns. And in each one, our job is to try and put one, just kind of like a Sudoku puzzle, one of each color in each row, in each column, and in each quadrant. So if I was going through the whole activity, we would do it by saying, all right, we're going to start with row 1, column 2, and we are going to look at all of the blocks that are missing and figure out what goes there. So if I look at row 1, the colors that are missing in row 1 are red and yellow. the colors that are missing in column 2 are blue and yellow. And in quadrant 1 would be green and yellow. So you heard 3 different answers for each one, and there was only one thing that was the same in all of them, and that was yellow. So when I go into the next one, I would say, okay, we're going to put yellow. We're going to go through just what I did. So missing in row 1, quadrant 2, or I'm sorry, column 2, quadrant 1, and then yellow. Yellow goes in there. Now, what I would tell the kids is after we've done that, we would do one more, and then I would ask them to see what pattern it is. So they would then come up with the pattern that says, I am looking at what is in the column. That's my X. What's in the row? Of those, just one, then I know what the answer is. If I come up with 2 things that are missing, because this time I would not because of the way it's projected up there. But if I came up with 2 things, then I'd have to come back later because I don't know which one of those 2 things it is. So they would come up and create. So here now we have added the blue. Whoops, sorry. I'm going to go back. And we would ask them to then create the algorithmic solution to this. So they would say, well, we look at row X, we look at column X, we look at quadrant X, or we could do X, Y, Z, and then we see what's missing from all 3, and that tells us what belongs. And so they would have to finish this out. So we would finish it out. And then I might ask them to come back again at another time and create their own. So those are kind of the things that they would be doing. This shows them how to solve that with an algorithmic process. Okay. And like I said, I didn't go through the whole thing because of time, but this is the way that we would do a hands-on activity to get them ready, thinking about what we're going to do with a program. So what are the units in this course? Well, what is a robot? Improving a design, troubleshooting and debugging, testing and evaluating solutions, one on sensors, one on variables, arrays, Boolean expressions, conditionals. Then we go to compound conditionals. And then we have 2, as I told you, career and physical computing culminating projects. So we have a lot of different things going on over this semester, and each of them are tied. Each of those 8 units that precede are tied to the culminating project. So we wrote this with the end in mind. We looked at the standards. We wrote the rubrics for our physical computing and career culminating projects. Then we said, all right, what do they need to know in order to be able to succeed at the end? And that's the way we wrote the units. So what's in a unit? The lessons are 45 minutes in, as their base, but a lot of the lessons are 90 minutes. So that may take you 2 days if you are working on a 45-minute schedule. And then sometimes they go up to 135. The culminating projects, of course, are much more. We have engage activities that lead the students to the focus of the lesson, just like what you did there where you were seeing that algorithmic process. Those are the type of engage activities. So they're going to be hands-on engage activities that teach a student what we're trying to get at to then really be able to focus the rest of the lesson, their exploration, guided practice, moving to open-ended challenges and modifications within a lesson, which is why you can see why many would take more than 45 minutes. Then there are some mini challenges, all right? Mini challenges are usually 90 minutes, and they are an open-ended based on what did we learn in this unit. It's the last part of the unit, and now we're putting it's all been application, but now we're applying without you getting that, guided practice. Now it's all on you. And then we do a connection to careers. So every unit contains those. So let's think about this. Remember, we're talking about a high ceiling. What could come after this? Oh, an introduction to Python 1 and 2. And what's the beautiful thing about this is that it is going to go right in that Spike app. So in the application, so the Spike app has the Scratch-based, which is what the course is written in, and then you can move over and in the same computer program use Python. And you can go through the lessons on learning how to use Python in a hands-on way. And if they complete Introduction to Python 1 and 2, which could be in 9th grade, could be in 10th grade, they're ready at that point then to take, not ours because we don't offer this, but another company's certification course for Python, and they will be so much more successful because they will have had this hands-on opportunity to learn and really understand the syntax and the way that you call up functions and arrays and Boolean logic and that kind of stuff within Python. So we give you this great way to grow your students. And I was telling you that it is possible to put it in middle school or in high school. That's true because a lot of times it depends on the developmental readiness of your students. Python generally requires that you have algebra. So some kids are ready. I taught 8th grade algebra, so I know some kids are ready in 8th grade for that algebra, and some kids are ready in 7th grade, but not everybody. So it may be that this is a great course, especially when high schools start requiring computer science for that 9th grade. Developmentally, that's where they are. Then let's put them in that fundamentals of or foundations of physical computing, and then let them run after that. Some kids, that's going to be what they get and they don't need any more. And some kids are going to need a lot more. So we're trying to meet them where they are and give them a hands-on solution. And why is that important? Because one of the things that has been found over time, and we've had enough time now to do the research and have people come and say, yeah, that's even without research as a teacher, I see it. When you are only on the computer, you are not working with anyone else, you're not collaborating, you're not communicating, you are all by yourself with you and the computer. One, they give up quickly. When they come to something frustrating, they don't have anybody to share that with. They don't have anybody to help them get out of the hole, right? So we need to provide that. And the other is the hands-on gives them a chance to see, somebody else was able to figure that out. I now know that it's possible. And that makes me go and persevere a little longer. But it also gives me the opportunity to go and say, hey, Sonya, how did you get that to work? And she's not going to just say, well, here's my program, go do it. Or here's my model, go look, go build exactly mine. She can look and help me learn from that. So I really appreciate having the hands-on and the collaborative piece. So what kind of questions so far do you have? Does anybody have any questions at this point?
Any questions thus far?
Well,
Kelly, you've done such a great job. Everything.
Seeing none, then I'm going to move on. And that is, I want to go through one of the things that we know too is that when you are teaching, it doesn't matter what it is, if you understand the content, you understand the pedagogy, you understand the classroom management, you are going to be a confident teacher who goes out and your kids grow like crazy because you have all those parts. What we know is that oftentimes computer science, STEAM, they just aren't what we learned when we were in school. We are self-taught at this point, or we've had just a small amount of one and done professional development. And we know that's not the best way. So what Lego Education has done is we have our in-person or virtual, but we love the in-person training where we come in and work with the teachers who are going to be teaching, instructional coaches who are going to be helping. And then we also have the self-guided learning. So what I'm going to do is I'm going to put into the chat for our session, I'm going to put in this URL and let people go to it. And you need to be able to, hang on. Oops. You need to be able to log in, and then it will ask you to confirm your login. So I'm going to have you do that, and I'm going to go in myself. So I'm going to stop sharing this screen. And then I'm going to bring that one up. And share with you. So while my computer is slowly getting there. I'm still seeing the what we call the circle of hope, when it just keeps rolling and scrolling. So it's rolling. Eventually it's going to come in. All right. We now have the circle of hope has become real. So I'm going to share my screen again. So once you get in, what we would like is you to go down to Lego Education Learning Resource Room. So I'm going to type that in case I have moved from this screen by the time you get in. Go Education Learning Resource Room. And I just wanted to show you some really quick things. Then we're going to go and look at Spike as well. But some really quick things. When I go into this resource room, Wheel of Hope, I'm going to start with Learning with Lego Education. So I'm going to go into Learning with Lego Education. Again, I'll type that into the chat. And you'll see that there are 4 different what we would call little learning bursts there. And they are what? 5 minutes apiece. So we are not talking that everything in here you have to sit for an hour. That's not true. There are small things. So one of the things that I would definitely look at is that learning through play, because that's critical. And if you've not used the 5E method, which probably you have, but if you have not, then just doing a quick, learning resource on the 5E instructional model. But getting to know that ability, and these apply across. So learning through play and the 5E instructional model, they apply across everything. You don't have to have a Lego brick in your classroom for those to apply. And that is similar to what are some other applications that are within this professional development. So I wanted to show you that because those are so quick and easy. Everybody should be able to access those. And then I also am going back to the very first page. Wheel of Hope. flying again. And instead of going to the learning resources, I'm going to pick Spike Prime because that's what we're talking about today is Spike Prime. When I go in there, you'll see I have 4 areas that I can choose from: STEAM concepts, 21st century skills, pedagogy, and classroom management. In each of these areas, you're going to find lessons that you can look at. And one of the biggest things I think from being a teacher and from my experiences, I rarely ever got to watch another teacher teach a lesson and then do some type of reflection with them. Never. I mean, I taught years, but it was always somebody, an administrator coming in and watching me teach, writing it up, talking to me, and that was the end of that. But I didn't get to see the craft being done by other educators unless, like Sonya and I would plan a lesson together and we co-taught. That was the only time I ever saw another teacher teach, which, I mean, depending on your middle school, if you're teaching math, you're not often working with the, English teacher, let's say, kind of thing. So these 4 areas have learning bursts and learning quests, and you will see real teachers in a real classroom, some virtual with masks on, some in classrooms with masks on, some before COVID hit and they don't have masks on in real classrooms. And then the teacher, you're seeing real kids, real teachers, and then the teacher has a reflection and they ask you to reflect on it. And then how would you handle that situation? Now, we're not saying there's big problems, but we're saying, how would you handle it when a student's model isn't working? They are, how do you handle that? So here's the way this teacher handles it. There are more than, there's always more than one way. And so then you get to reflect and say, what would I feel comfortable doing? Because it's not one right answer. So we go through and you have the ability to go into any of these. All right, I'm going to go into STEAM concepts for just a minute. And I'm going to show you that you have things that are specifically about the product, Spike Prime, but you also have, look here, for 15 minutes, decomposing a computational problem. That's going to help me teach computer science. And even if I know how to decompose a problem, I want to watch somebody else do it and say, oh, I like my way better, or I never considered trying that. Oh, that's a great activity, and I've never done that before. And you'll see that the longest one on this is 45 minutes. So we have a learning quest being longer, so it's 45 minutes, and a burst shorter, about 15 minutes. And so it gets you started, but I think that's doable. Now, one of the other things with the professional development is that we have the ability to come in and do that face-to-face training, and it can be competency-based. So we would come in and really focus on project-based learning or whatever skill, we work out. And then you can go into this PD platform, and there are some other things that open up once you're in competency-based training, and you can earn micro credentials. So I think this is a very comprehensive plan so that once, you walk out of that first hands-on training, you don't go, well, that was it. I mean, I think back to some other technology that we had in our school, and smartboards would be one. And they paid for a couple people to go get training, and then they were supposed to come back and teach us, but they only went one day. They never had any more training. So we had glorified whiteboards. who were used as a projector screen, and we really never got the benefit that could have been had from having a full training and then ongoing training, because you have to practice a little bit, then you're ready for a little bit more. And that's the beauty of this online support and coaching that we also do. So I'm going to stop sharing my screen again, and I want to give you one last little bit of information, and that I can bring it back up, and is going to be getting to the end of my program. But I do want to talk about one more thing, and that is the community. So again, another support mechanism that you have is the LEGO Education community. Community at LEGO Education, or not at, but community.legoeducation.com. It's a global community site, which means that you might see someone in there and they're asking a question and their English isn't, perfect. And that's because that's probably their second or maybe their third language, but we're learning from each other and finding support from each other. And, if I have a question, here are teachers who are using the product just like I am, and they can help me. Or, man, I just came up with this great idea and it went fantastically in my classroom, and I'm really excited, and I want to share that with you all, and that you can share it in the community, and you can bet that you're going to have a bunch of people utilize what you've done, so that you can feel good about, well, I shared it and now I know at least 10 other teachers around the world. I mean, I could have people in China, Japan, Britain, Australia, all doing something that I created as a teacher. So I think that's neat. But the best part is it's give and take. So you can go in and find best practices. You can ask a question. Hey, have you ever had this happen? And they will respond with you. And then you can also share your great ideas. So it's really a great resource. So mostly I just want to, ask if there are any other questions. And thank you so much for talking to us. Now, if you are interested, if we've piqued your curiosity and you're interested in looking at any of those computer science courses, you can contact Sonya, and there's her email address, which I will type in to the
and I would be glad to assist in any way, shape, or form, and look forward to some extended conversations with you all.
Absolutely.
And Michelle, I will send you an email also.
Oh, good.
Get touch base.
So if you don't have any other questions, I would be more than happy to give everybody a couple minutes so that you can take a quick bio break and then be back for something else.
Are there any questions? Thank you, Julia. We appreciate your joining us. And thank you to everyone. Are there any other questions that we might be able to answer for you? Well, seeing none, we say thank you so much for coming. And you have a great rest of your day. Thank you so much. Enjoy the conference.